Can you hear me okay? How about now? Ooh. I feel awesome with this. So thank you for coming tonight. This is Orchestructure, if you've never been here. To briefly talk about DevOps Days Detroit, which was just a few weeks ago now, which myself and Archie emceed, and we had a really great time. There's videos from that coming out really soon, and there's some amazing talks from some amazing people in technology. Yes, Orchestructure has the meeting this month. We have a meeting next month. That'll be Matt McLean with Criteo. More details on that forthcoming. And then no meeting in December for Christmas. So I wanted to give a shout out to our sponsors, Ithaca. Obviously, they've supported us greatly this year, and they were providing the food as well today, the cookies as well, which was a nice touch. And then Lamasoft, which has hosted us many times and will do in the future as well, plus Fly.io and the CNCF and my company StockX. So I thank everyone for coming today. I wanted to give Archie just a couple seconds to talk about Ithaca. And thanks, guys.
This is my sponsor minute. So you're at Ithaca today. Thank you for coming to visit us. By accepting our cookies, you agree to our terms and conditions. Okay. So we run the website jstore.org. You can check that out. It hosts basically tons and tons of academic articles and books and other great stuff coming soon. And we've got open positions. How many open positions do we have, Eric?
At least 5.
We have 5 open positions, especially web developers, I hear right now. Is that right? Any?
Multiple front end.
Multiple front end. So if you are a front end developer or you know a front end developer, we would like to talk to them. Okay, cool. Back to you, Mario.
Yep. Thank you for keeping that frame inside of a minute. And now, Matt Farina on Helm.
Hello, can you all hear me in the back all right? All right, I'm not going to use the mic because I'm going to stand out of the way of the screen, hopefully, and because I got slides. I don't know how well you can read them, but I do have slides. So hi, I'm Matt. I work for Samsung SDS. That's, if you don't know, Samsung is a conglomerate, kind of like Google or Alphabet with different companies in it. And SDS is one of those companies. We tend to deal with IT services and things of that nature. So we do AI, cloud, blockchain, things like that. We do it for Samsung sister companies, as we call it, and other companies too. I also spend most of my time, and I'm a co-chair and co-founder of Kubernetes sig-apps. So I spend a lot of time in the Kubernetes space, lots of time doing infrastructure, but a lot of it with an app focus. How do you run your applications there? Which is what pairs with Helm. Helm, for those of you who don't know, I was told that y'all know Helm. How many people in here know Helm? All right, fantastic. For the few of you who don't, it is a package manager for deploying things into Kubernetes and sharing things, because we like to share code, right? We like to share our applications. We like to share stuff. And the way we tend to do that is with package managers, whether it's a platform or programming. And so when I came here, I was told everyone would know this, so kind of get into some advanced topics. So I'm going to talk about one more advanced topic and then get into Helm 3 and where it's going. And so the first thing I have is a question. Did you know you can sign and verify charts? Did you all know that? How many people in here knew that? Besides that, so I'm going to talk about how that works today, because it's actually a pretty powerful thing. Does everybody know why you want to sign and verify things? Do people know that? All right. So here's the thing. When you download something on the internet, how do you know it's actually what the people said they were shipping? That somewhere in there it wasn't hacked, because we've had cases where even distributions like Debian and things like that have had their servers hacked and they've replaced it. How do you know that a server wasn't hacked and something was replaced? How do you know that the person who shipped it, you actually got what they intended to ship? There are attack vectors through people breaking into servers and changing up what was shipped. With open source projects, there are numerous major cases of this kind of thing happening. So how can you do that? The way to do it is somebody actually signs it, and then you verify it, or somebody distributes a hash, and you verify that hash because it says the content is what it said it would be. You want to share the hash in a different means than you're actually sharing the application. because they can compromise where you're shipping it from. They can compromise the hash. But this is the idea behind of signing and verifying things. You know you're actually getting what's intended. And by people just grabbing stuff and using it without ever signing it, there are a lot of cases of stuff being intercepted and hacks happening that way. And so this is why it was baked into Helm, because you want to be able to have these kind of enterprise features. You want to be able to do this for the people who want that, for the people who need that assurance. Because if you're a bank, if you're a large company, you'll want to pay attention to those details. And so it's baked into Helm. And it's actually baked in pretty easy. Here's some basic Helm commands. Some of you probably know this. Helm create, my chart, right? Helm package to package it up. Oh, but here, we can actually say sign it and use this key from this key ring. And what it does is it'll actually sign it. And then you can use Helm verify, and you can verify it. And you just say the tarball, and it'll actually verify. And it'll verify it against a PGP signature and a hash and things of that nature. Flags on fetch, on install, to go ahead and verify things. This looks pretty simple. And the way this really works under the hood is Helm actually creates what's called a provenance file. And the provenance file, here's an example up here. It's got the top part of it is the chart YAML file. You can actually read that. And then underneath it, there's files. And in this case, this is grabbed out of docs. So it's an example. There's a SHA. And so Helm can verify the SHA of the file because it's been transferred here. And then underneath it is the PGP signature for the file. So we've got multiple ways to verify things. And that's what's encapsulated in a provenance file. So when you push it and you move it around, you would also move the provenance file along with the tar. Again, from the docs, if it doesn't match, it'll tell you. Right? You can verify and it'll say, oh, it doesn't match. We know. And in this case, the example is the SHA. But quite frankly, honestly, due to an interesting technical glitch, none of these commands work for me. So I couldn't do a demo if I wanted to on this laptop because they're actually broken at the moment. It worked for me, not because of Helm, but because of GNU PG. Anybody familiar? How familiar are you all with this? With signing things, doing this? No? Okay. So in version 2.1, you notice it's a minor increment, not a major increment where you normally break APIs. They actually changed their format for storing keys locally. Yes, they did this. And so they did it for performance. So the key ring used to be a PGP file. So every time you went and you looked for a key in there, it had to parse every single key. Now, if you've only got a few keys in there, or maybe 100 keys, that's not a problem. But people who use this have thousands of keys. So it ran into performance issues, right? So they came up with the Keybox file format, and they'd been using it for some things for a while, and then they switched to this. And of course, I've got a newer Mac. When we do have an open PR for a process for changing it up, and it's going to look like what I'm going to show you in a minute. And Helm actually has a fix for this right now. If you're using this, you can actually export your keys to a key ring, and then you can sign from that key ring, and you can export so there's the private at the top, the secret keys, which is what you use for signing, and then the public keys, which is what you use for verification. And so here, in the first two, I export the secret keys, and then I package it using those secret keys. And then on the last two lines here, I am exporting the public keys, which can be anybody's keys, right? I could get anybody in this room's public key. I can go online and get public keys. My public key is shared in several places because that's what you do. You can use public keys to sign and to verify and do those things, right? So, and then you can use that for verification. But another funny thing, that doesn't work for me either. Familiar with smart cards, things like that? Okay, so with those, you can put your key onto there, so that way it can't come off, and your stuff goes in there to sign it, to verify all of it, but somebody can't get your key off of it. So it's a secure way to keep that key and to carry it around, where somebody can't hack into your computer and get it off. And I've used YubiKeys for a while, but you know, the Open PGP package produced by, it's one of the Google packages written in Go that Helm uses to do all of this, doesn't support smart cards, which is where it says the hash for S2K is. So That also doesn't work for me. It's a big pain in the neck, quite frankly. And it left me wondering the question, and I went around asking the people who wrote this, why didn't we just pass through like Git does? Why didn't we just do the same thing Git does? Which there's actually an open proposal in Helm for probably Helm 3 to do that. But Helm has plugins. How many people know about Helm plugins? Yes, you can have plugin that can do Helm S3 plugin, because you can host a package repository in S3. And what you can do is you can have your scheme, you know, instead of HTTPS, you can have S3:// endpoint to a bucket. And it works with authentication and all of that if you have the S3 plugin. Because Helm says, oh, I don't know how to handle this. Is there a plugin installed to do it? The S3 plugin does. Your transport is handled, along with your authentication and all of that. Because Helm has plugins that allow you to do a variety of things. And one of those plugins will actually pass through to your system's setup. And so here's what a basic command would look like. And I actually think this is easier, because I can say Helm create, and I can say Helm package, and then I can just say GPG sign it. I don't have to pass in any of the rest of the stuff, and it just uses my secret key, right? It just signs it. It uses my key. And then verify, it just knows the keys to use, because it's the same thing you sign Git commits with. You can, if you're using something that works with those other methods, the previous ones, it still works with things like install -- verify, where that works. Because under the hood, and this is one I generated the other day, it creates a provenance file. It does everything the Helm way and works with the flow, but it does a pass-through. And so that's an easy way to do provenance files to sign things. And while I'm talking about it, anybody know Keybase? Anybody know Keybase? It's kind of another way to share your credentials and to export credentials, get other people's credentials, and import them to try to make this whole process easier. And in the Helm docs, we actually have docs on how to use Keybase if you want to get into signing. There's even a Helm Keybase plugin to sign using Keybase to do all of this stuff too, and to verify that way. And so this is a way in which you can sign and verify to actually ship and know you're getting what you want. Now, unfortunately, the community repo doesn't do this because those packages are all built with automation, and we couldn't figure out a good way to put a signing key somewhere we trusted with automation in order to do that. Now, we are going to move to a distributed chart repo setup here soon, and people will be able to distribute things to their own repositories, and then they can sign them. And I know I'm advanced topic, but I know some folks want to know about Helm 3 and what's coming down the pipe. What are we doing? What are we changing? And why? So anything I say here is subject to change because we haven't shipped it. We haven't even shipped an alpha. Lots of development. We haven't shipped anything. So anything here is subject to change, but some of it's already been done. The reason for Helm 3, so Helm makes a big push for semantic versioning, right? API changes, you increment the major. Everything else, we increment the minor, and patches are for bug fix. We are very big into this. And the reason for that is if you need stable software, you need stable expectations, right? Kubernetes, every minor increment breaks the Go API you're importing if you're importing everything. There are all kinds of other API changes and frustrations. And one of the things of Helm is we're not going to do that. We're going to try to provide that stable environment, that stable expectation and tool. And so to go to Helm 3 means we can break APIs, which is kind of nice because we've had a certain amount of design debt show up, things that we added on. We said, oh, we wish we could do this a better way, but it would require breaking the API. And people import Helm packages and use built on top of that, where every 3 months a Kubernetes releases a new client Go with a new changed API, you'll know that it's very frustrating if stuff is always changing. In fact, that's one of the things that slowed down Helm 3 development is because every time we upgrade for a version of Kubernetes, it takes a person between about 2 weeks and a month to upgrade client Go because of the changes they make constantly. It's become a frustration. And we don't want to put that frustration and burden on others. And so we take breaking APIs very seriously, which is why we're excited about Helm 3, because we get to break APIs. So the first thing, goodbye, Tiller. Goodbye, Tiller. And by the way, in the Dev3 branch, Tiller is already gone. For those of you who don't know, Helm v1 did not have Tiller. Helm was originally created by a company called Days that was bought by Microsoft a little over a year ago. And Helm for v2 merged with something Google and Kubernetes server-side component. And so when it merged, and the two companies merged, their ideas merged, Helm got the server-side element that Google had created for Deployment Manager. And it has not been as nice as we would have liked. It has been a pain because do you run multiple tillers? How do you secure tiller? What about tiller and RBAC? It's not always the most intuitive experience. And so we're very happy that it's gone. Quick sidebar, you can actually do this in Helm version 2, where you run tiller locally in your system, and then you talk to the cluster that way. And those of us who develop Helm, we actually do this all the time when we're developing tiller. We don't like push a container, then pull it into the cluster. I just run tiller and terminal, and it just works. But somebody actually made a plugin for this, because we talk about plugins that you can use to just do it. And it'll make sure the version of tiller that you're running matches your version of Helm, and it just works. So you can run this locally today without having to have tiller running in the cluster, and you can do it for different namespaces, all of it. But that's the end of that sidebar. Then we get into state storage. Now, in Helm version 2, we use config maps, because that's all that was there at the time Helm version 2 came out. We didn't even have secrets back then, right? But now we have a lot more. We've got custom resources, CRDs, secrets. There's lots of options. And so for Helm version 3, we're looking at custom resource to handle what's in details inside of a secret. And that's just because secret and secret handling gives us capabilities that nothing else has, as far as pluggability to other systems when your clouds are working on better storage and encrypted storage, all these things. It gives you kind of that security element if you're sticking values and stuff like that in it. And so that's where we're looking for those things. Because Helm, it's just, not everything in Kubernetes has things like rollbacks, and it doesn't always group things well. And if you've got an application with a lot of resources, and you're gonna roll them back and deal with changes like that, you wanna actually have your state at that point. And so values, or secrets, let us store that. All right, we're going to an event-driven architecture. This is in flight, where there will be all kinds of internal hooks. And this gets more interesting in a minute, where you can access data at these hooks, like your chart data, your values, capabilities, all kinds of stuff at certain event points. Now, this will be a little bit more of an advanced feature that really plays in really nicely when we get into chart extensions, because you'll be able to write extensions inside of charts in code. Right? You want to do something fancy, you can code it. Now, how many people are familiar with Lua in here? Okay, we got a few people. We chose Lua for this because of a few reasons. One, it's pretty easy to embed in Helm. We looked at JavaScript, and quite frankly, JavaScript is not easy to embed into something. V8's great. Try and have a small team embed that into an application and then ship it on Windows, Linux, and Mac. That's not so easy. But something like Lua, it turns out, is really easy. So it's easy to stick in there. There's security measures. We're going to have a permissions file where you can say, here are the different system libraries you're going to use. Just like if you're using your phone, you've got to give it authorization to use certain things. We wanted that security element, so you can say, yes, you're allowed to use those things. So that way scripts shipped in charts just don't run wild on your system. You're now not just shipping YAML and templating, you're actually shipping code. Do you trust that code to run? If it's something that should looking around, you want to be able to opt into that and be able to see that. And so that sandboxing capability is there. And so these are kind of the reasons that we went after Lua, because we could embed it. It's a simple language. It's actually one of the top 20 most popular languages according to RedMonk, and it was designed to be embedded, so it's easy to put in. And it'll run on Windows, Linux, Mac, all of these places. So I could build a chart on Windows, and somebody can run it on Linux, and nobody has to be any the wiser, and it can do this. And that's kind of nice, because still like 50% of developers are doing their development on Windows. That's just, it's the most popular platform. And so having that cross-platform capability is nice. All right, library charts. You want to have a chart and import it and use that stuff? Library charts. We're going to have library charts in Helm 3. So that way you can take all those common things up and just keep reusing them. All right, this is one of the harder things we're going to try to do. And I don't know whether we'll be able to get to it. But UIs from these kinds of things. You can do validation of values files. There's lots of neat things you can do it. We want to go there. Actually, dealing with these schemas in Go and the libraries is one of our biggest shortcomings right now, because a lot of the libraries just aren't there in Go. You get into Node.js or something like that, they're there. In Go, that's one of our weaknesses. We're trying to find the best tooling to do this, and it's not quite there yet. So that's why I say it's on the weaker side. If we'll be able to land this, because we might have to go write some tools. And do we want that to block Helm 3 or come later? We'll have to figure that out. All right, a little thing. Hook annotations are actually going to be managed. If you're in Helm 2, if you have something like a job fire off and a hook annotation, it's unmanaged right now. It's not managed in Kubernetes, and it may not get cleaned up. You'd have to clean it up yourself, depending on the other hook annotations you have. In Helm v3, they'll be managed. It'll all just clean up at the end. All right, here's one of the interesting things we want to do. The controller model. So Helm is a push, right? What if you want to pull? You run a controller in a cluster, it looks for changes in a repository. Oh, you've got changes there? We'll pull it down and install the upgrade. Instead of doing that, actually have Helm run in a cluster as a controller. It's almost the Ansible versus Chef model, where Chef looks for updates and changes there and is able to pull them down to many machines. We're looking at implementing that model, because if you've got lots of clusters and lots of stuff distributed all over, right? That can break. Oh, one of them broke going out. Do I redo the whole run and upgrade it again everywhere? How do I deal with that? It's kind of that distributed systems problem, but we're looking at it from a controller standpoint of a separate app. And it'll be able to import the same package library that the Helm CLI uses, because there's going to be one package. And you can import that today in Helm v2. All right, more plugins. We want to make it easier to do cross-platform plugins, because we've got plugins today. A little bit easier, where you can specify run this command if you're on Linux or Windows or things like that, because then you can tap into specifics that are relevant to that platform in the plugin. And since we've already got Lua in there, why not plugins in Lua too? Because then you can, instead of writing a shell script, you can write a Lua script, and then everybody can use it everywhere cross-platform, because not everybody has that. So Lua being exposed for plugins. All right, and how about easier installation? Right now, installing plugins requires you to actually say, go get each plugin. So if you want to pass that around in a team and have a set of plugins, or you have a set of plugins you need for an environment, it's a bunch of commands to do that. So we're looking to make it easier by saying, when you do Helm init, here's a file. Go fetch all the plugins there. So we're trying to make plugin handling easier, because it is a more advanced thing, but it's incredibly powerful. All right. So let's start. Has anybody in here used Helm serve to run a local repository? You got folks. Okay. You are the first folks I've ever met who've done this. We've been looking around for people who do this.
I was just messing around when I was replying.
All right, just messing around. See,
Yeah.
nobody has ever used this. It was put into Helm v2, and we can't find folks ever using it. So, Artifactory, they're using Helm serve?
I don't know if we're using Artifactory.
Using Artifactory? So Artifactory implements the API. We actually work with a lot of Artifactory folks. In fact, something I'm going to talk about here in a moment is something they brought to our attention, and we're working with them to fix. They've been great partners in working on Helm upstream, because they know a lot about package management, and they've been sharing some of that wisdom with us. All right. We're also going to have push to repositories, where you can push. And a lot of this is working with Chart Museum, which is kind of the dynamic server, where Helm can generate a static repository. Chart Museum can generate dynamic repositories. And you got access controls. We want to deal with logging in and pushing things. Maybe it's S3 with the S3 plugin. Maybe it's Chart Museum and HTTP, HTTPS. We're working through all of these different things and making it pluggable, so that way you can push right there without having to have extra things in the way. Now, this is actually where the folks at Artifactory helped us. So right now, there's an index.yaml file. In Go, especially large YAML files, ridiculous amounts of RAM, and it's slow on performance, right? Especially compared to JSON. And part of the reason for that is in YAML, you can reference another part of the YAML, so you can't just stream it as you go and be smart. You have to parse the whole darn thing. And so say you get a really, really, really large YAML file that's, many megs in size, which isn't unheard of, especially with machines transferring this around. Your memory can dealing with those YAML files. And that's how we've done index files. And so they actually went off and looked at, well, what would happen if you're using this in CI and CD and you're delivering stuff there all the time? How big can these things grow? And they showed us examples. And so, we're talking a couple hundred meg YAML files examples to watch how the scaling would just explode. But we saw it didn't scale. And so we're going after a V2 format written in JSON because JSON's far more performant to deal with, especially the libraries in Go. And we're going to break it up. We'll have an index.json file and a chart.json file for every chart. And that will allow us to be far more intelligent in how we pass information down and deal with things. Now, a lot of this here is for figuring out metadata. And it's probably worth touching on. The reason that we do it this way, by actually downloading things and checking it there, is because, okay, say you just said, okay, well, we got these servers, they're dynamic, we'll just push our queries over there when we got to search for things, when we got to look up information. We'll just push it to the server. Well, quite frankly, they get all kinds of metadata. Now, if you're in a corporate environment and things like that, lots of times you don't want to go tell Google, well, here are these packages that I'm searching for. Here's all of this information. You want to have a certain amount of privacy. And if you do those searches locally, you get those privacy. If you're pushing all that information up, whoever's running those servers gets piles of metadata on you. And lots of folks personally don't care about this. Lots of businesses who use these tools do. And so that's one of the reasons that we actually pass the metadata around and do a lot of this searching client side. Because it's better that way. And it's actually modeled after Debian, if you're familiar with apt-get and that. The same kind of thing is modeled after the way they do it. And so that's the reason. And then if you had to push it server side, you couldn't use static repositories. You couldn't host it in S3. You couldn't host it off a flat web server. You couldn't use GitHub pages to host a repository, which you could do today. And we wanted to enable static repositories to continue to exist because they are wildly popular. So that, in a nutshell, is the Helm v3 plan for what we're going to change from today. It's a lot of removing design debt, cleaning things up, and then trying to remove some features people didn't use, modify and adjust to what people do use. All right, any questions? The slides are available online there if anybody wants to get them after the. Through that really quickly.
I got one.
Yes.
So you're talking about like doing Helm push. Is there talk of having like a public Helm repository a la Docker Hub?
No. There's a few reasons for that. One, somebody's got to operate it and pay for it. And that's a lot of money and operations people. And like most CNCF projects, this is funded by volunteers. So we don't really have the people to chase after that. In fact, the community charts repositories, the stables and incubator, they have scaled to a point where we can't handle them anymore, which is why we're going to do distributed chart repositories. So we're going to allow you to have, I could run a chart repository, you could run a chart repository, you could run a chart repository. Is anybody familiar with Composer and PHP here?
Yeah.
So the way that works, for those of you who don't know, is your PHP packages are hosted all over the place. GitHub, GitLab, wherever. It can be in your own Git repository. I think you can do Bazaar, Mercurial. There's several different VCSs. You can have these things all over distributed. And there's packages. Composer is the package manager, and Packagist is the site. And what it does is it's a central metadata search. I can search for all the packages distributed everywhere, and then I can choose which ones I want to get. Now, I get them from the source, but it gives me one central place to go for everything that's public. And that's what we're going to do, because that's a level of detail we can operate, and we do have the people to deal with, and we do have the people to scale something like that. And then there's the fact that the CNCF, which Helm is now under, Helm used to be part of Kubernetes, and it went into the CNCF with Kubernetes because it predates the CNCF. And then Helm became a first level sister project to Kubernetes. It's an incubator right now within the CNCF. It is an enabler. It is not trying to eat the world in owning everything. It wants to enable things. So a company like right? Somebody else like CodeFresh, which the Chart Museum maintainer works there. They have chart repositories powered by Chart Museum. They could host public ones, right? It then becomes a platform for many people and many companies to host things, and it's an opportunity rather than us owning all of that. And if you know NPM, that's a big thing for them to own. Now they're VC funded. We'll see how long that continues because so much is in there. But it's a big thing when you have to own something like that. And it takes a lot of people and a lot of money you can't put elsewhere. And we were looking more to enable people than to control everything, if that makes sense. Mm-hmm. Yeah, and so Postgres and others, and they can maintain it themselves in their own repositories using their own, right? Because you make a doc change, you increment the version. Not everybody's going to do that. You don't always need to do that. Our tooling and our setup is designed that way, and we wish it wasn't. And we really want to enable other people to have their own processes that work within their workflows, but still work for something like this. And that's the goal. Well, certainly.
Okay. So let's say you're an organization and you've done chart installation, but you haven't really gone to chart creation. I understand you can't commit to release dates and whatnot, but your advice is to, should we wait? Should we not wait?
For Helm v3? Yeah, I don't know. We're already behind schedule because we've had to put more time into dealing with Kubernetes changes than we had anticipated. We're hoping for an alpha at KubeCon in Seattle. Hoping. If you're really into business, your production stuff, I probably wouldn't. Yes, all right. I probably wouldn't start using it in production until Q2 next year. Helm v2, we will still support for a time. We're discussing how long. I started the discussion, I said 6 months, because that's a typical enterprise thing. If you want 6 months of support, when you do a major version change like that. So we're talking through how long we'll maintain Helm 2 for, but it'll be around for a little while because we can't just expect everybody to switch right away, because when Helm v3 comes out, there'll be bugs. It's software. That's just how it works, right? There are going to be little gotchas. We're going to have to work through it, and not everybody will be able to migrate right away. And we know it. So we want to run all of the V1 charts, but there will be certain breaking changes to them. So one of them, and I'm hesitant to tell you, but the OpenStack folks have this crazy feature that if you search GitHub, everything on GitHub that's public, don't use this feature. But they have these crazy features that they got us to put in with the way charts can talk up and down to each other. So you can use Helm to install OpenStack. And the code, yeah, you can use Helm to install OpenStack inside of Kubernetes. And you can run OpenStack and VMs and all that in there. And you can use Helm to install it. And there's charts for this. Yeah. Why?
No. What?
Yeah. And so to support that, there's some crazy things that were added on. And I don't think those are going to make it into Helm v3. Like, these are some things, but you'll be able to do all this through extensions. And so where those things break in V1 charts, they're not. Your standard V1 chart case, we want you to be able to just say, install this V1 chart and not know a difference. That's one of the goals of this, is to make that compatibility. Because even though we are going to V2 charts, we're going to have extensions and things like that, we understand that if we just break most people, they're going to walk away in complete frustration. That's a terrible user experience. And so we will try to make most people be able to just bridge that and run their V1 charts out of the gate. And we'll try to make that easy. So I should say, for most folks, this isn't a problem. I say, come on, we got to do it. I'm talking to one of the guys who knows, Adam, who's working on the innards. He's like, we can't do perfect compatibility. And then he starts showing me things, and I go, I didn't even know this was in Helm. I'm scared that this is in Helm. And he goes, yeah, you should see the code that powers it. I don't know if anybody in the world which is one of the nice things. We get to clean this up in V3, but it will break some compatibility things. But we will have a path forward for those folks through the Lua extensions. And so that's part of that overlapping support time to help folks make that change. And we'll help with that. We'll give snippets. We'll provide advice because we want to guide that along. Did that help? Did I answer your question?
Yes, it's perfect.
Yeah.
Isn't that Helm controller just essentially
Slightly different use case because Tiller, I mean, it had a web API or a gRPC API. You could interact with it. You could get it to do things from elsewhere. But nobody ever did it, right? There's maybe one or two people. There's a couple of cases of folks creating REST APIs that would talk then to gRPC in because folks know how to talk REST. And it really didn't take off. So it's sort of like Tiller, but at the same time, it's a different use case because Tiller was meant to just do that server side. It's not going to detect changes on the outside. It's not going to be able to do some of those other business logic changes because it was just being told to do things in a push format. And we're actually talking about maybe looking at different ways of doing things and having a controller work maybe more in a chef way, things like that. It's a slightly different use case, but it is still a controller running in the cluster. And it might even be similar to some of the stuff like that Weaveworks has started to do now with Helm v2. It might be similar along those lines. And in fact, one of the guys at Weaveworks is the chair of the CNCF Technical Oversight Committee. And so he's somebody we get to work with on a regular basis. Were there any other questions? It can be about this or anything Helm related.
Oh, mine's more Kubernetes.
Or Kubernetes related. I'm fine to answer questions on anything.
So how would you try and change Kubernetes from being so dependent on client code like that? Because I'm like a minor dashboard maintainer, and we have to like release a new dashboard instance every time they release a new release because we have to update our client code.
All right, so here's what I would do. Create another Go client that's meant for all the rest of the consumers out there, and let API machinery folks have client Go. Because they have intents, they have reasons that they're doing things the way they do. They've got reasons they've got it. Client Go is massive, by the way. If anybody hasn't looked, it's like 1 million lines of source, and if you embed it in your app, it's somebody was saying it's like 16, 17 megs added to your binary by including it.
It is.
Right? It's a monster. But they do a lot in there, and there's a lot of reasons and a lot of legacy that ties to the rest of the way Kubernetes and its spaghetti code works, because there's a lot of spaghetti code in there. And so I would say we just need a separate Kubernetes Go client that's much lighter. We could probably generate a lot of it off of the open API specs. In fact, there's folks who've tried to do some of that, and you have a much more lightweight client that meets most folks' needs. There's actually another one out there, I think it's by Eric Chang, that does something like that. But it would be nice to use some of that, to maybe have an official one, something more lightweight. I wouldn't say ditch client and it's useful to them. But I think for most folks, a lighter client will work. Yes?
Any planned integrations with AppCRD?
That depends on how far along we get with the AppCRD. Now, for those of you who don't know, I'm one of the maintainers of the AppCRD. And so it's funny because I've been investing in Helm lately. We haven't been moving along with the AppCRD fast enough. Hopefully later this year, I'll have some more time, and some of us will. The AppCRD, for those of you who don't know, it's similar to things like your chart YAML file and other things. But when you get an instance of it running, it gives a common metadata. So something like dashboard could look for everything running AppCRDs and see the applications and list those. And that could be a whole collection of assets are described by it. And then you can do things like owner references on deletes, and you can do with cross-compatibility. There's a lot of fun options here. I think we have a beta out for it, although I don't know that we tagged it. I think somebody asked us about that. But and Google has done some stuff with it. It's kind of going to depend on its pace. Now, if we aren't able to bake in functionality for it because there's not a V1 out, it's not wholeheartedly there as a core thing that we automatically do, because it's a CRD, you can just stick them in there and they'll work. And we could actually make the generate function automatically create one for you, or the Helm create function when we generate it. We can have that automatically insert one for you. We haven't exactly figured out our strategy on it, but that's because we probably need a look down on the application CRD and come over the, and of course, since I am one of the maintainers on it, it's my fault. So I will accept that blame. Yes. Oh. Go ahead.
The charts repo, I noticed, like, I don't know if there's standards of those a lot of times. I feel like there's a lot of times like there's charts and there's things like operations or whatever I'm missing, and I have to keep my own version just to, like, you know, push it on the terminal. Or a certain plan, like, be free to kind of have some type of like templarized format that people are use.
I don't think so. If you use something like Helm Create, it'll insert the tolerations and all of that for you. It automatically generates those in Helm Create. But
Like, it seems like there's a lot of stable.
there are a lot that are missing those, and a lot of those have been around for a while, since before those were a big thing. You can kind of see the legacy of this carrying on over time, and things being added, and best practices being learned, and features being added to Kubernetes that you can now inject here, right? And so you can see some of the things that started off a long time ago that maybe haven't gotten those because somebody hasn't done a pull request. And back when it was created, it just wasn't a thing. And now it is a thing, and they are showing up. And so you can kind of see, if you look, especially, you know, me who's been watching the charts repo for years, you can kind of see the evolution of what's in there. A lot of templates, stick your basics in of what you wanted to change. And now there's business logic in it. Now there's logic in there to say, well, if you're in this case, do this. If you're in this case, do this other thing. And it allows people to do things like install a chart in GCE or GKE and install a chart in AKS. And it'll fire up and do different things dependent on the cloud, because the chart has the logic to make that portability happen. And so things have really progressed, but not all of the community charts have caught up. Some of it's lazy maintainers. Some of it's there's so much stuff. We're kind of overwhelmed, which is why we're going to distribute it, because it's easy to maintain a search system and then punt all the maintenance work onto all the people who say they want to own these things, because a lot of them haven't been coming back to maintain them, and that's just put a heavy burden on a small number of folks. I'm happy to be around and continue to answer any questions.
You can bombard him with questions. I just want to wrap up. Where can people find you? If they want to talk to you more about this or tell you how bad things are, you know, yell at you.
So
Twitter,
Matt Farina, M-A-T-T-F-A-R. I'm kind of that, like, all over the place. You can find me in Kubernetes Slack, CNCF Slack, Twitter, GitHub. My website was earlier, mattfarina.com. You can, I'm kind of all over.
Cool. And if people have ideas around Helm or things they want to add on or things they want to talk about, is there kind of a go-to source for that?
There is a Helm dev room in Kubernetes Slack, or there's always our issue queue. The Helm repo, github.com/helm/helm. The issues there. Every week, we actually have one person who signed up. They call them issue Sherpa. It's the one person who will go in and triage everything that comes through. And so we try to go through, label it, respond it, deal with it. So if you have something that comes in there, we may be lazy and not comment on it, or maybe we're busy and we're not able to right away to see it. And if there's a proper label or something like that, they'll label it and we'll think about it and it'll hit somebody's eyes. And so that's a great place if you want to submit something for Helm itself. There's also the Helm community repo, which is where there's suggestions and things for the broader ecosystem. So whether it's charts, chart museum, general direction, that's another good place.
Awesome. Thank you very much, Matt, for coming. And then I'll also send out the slides as well. We'll get the slides sent out to you guys, and then the video will be posted very shortly after this. So thank you guys for coming. Finish up the food and take care. Have a great night.